So today we will discuss about the problems from the lesson number 2 based on the chemical equations. Right here, first compulsory our equation must be balanced equation. Right, to solve any problem from the lesson number 2 chemical equations, it must be balanced equation. If balanced chemical equation is given, what to do? We have to make it balance first. Then we will go for the solution. For example, here C plus O2 useless to CO2 is given. Is it balanced equation or unbalanced equation?
C plus O2 gives rise to
CO2.
CO2. So balanced.
So here one carbon, two oxygens. So LHS count to RHS count is same. So it is balanced chemical equation.
Okay.
If you go for another example here, for example here, sodium reaction with water giving NaOH and liberation of a gas. Now check this equation. Balanced or unbalanced? Unbalanced. So what to do in this case?
Balance.
If any unbalanced equation is given you, then immediately make it balanced first. Right? Here, in making balance, what we are doing, just we are selecting suitable number, ice coefficient to put before the compound. Right? Anywhere. So here, I'm going to select suitable number to make it balanced. Here, hydrogens right side, I have 3, right? Left side 2 there. So 2 times 4, right side also I want 4. So here I'm placing 2 ice before H2O and before NaOH. So 2 plus 2 became 4 right side also. Then Na is disturbed. So put 2 coefficient ice before Na, then it will be balanced. 2 oxygens, 2 oxygens. Now it is balanced. After checking your given equation, then only go into the solution process. Okay, first step is check whether the given equation is balanced or unbalanced. This is your first step in solving equations. Right, first step is balanced equation compulsory. Right, make it balanced if not given. Right, make it balanced. Then only go into the solution process. Okay, then we will go for second process. So second step is finding masses. Finding masses, right? According to the question. According to the given question. Right? Suppose in the second question of your textbook, 230 grams of 230 grams of sodium reacted with excessive amount of water. So in the question, what is given? 230 grams of sodium is given. Right? Sodium 230 grams reacting with water. Not given. And asked what amount of hydrogen liberated. What amount of hydrogen is liberated? So here, is there any relation with the water? No, just it is given as excessive amount and asked to find out hydrogen only given sodium. So it is not related to water. So no need to take that into your calculation part. Right? No need to take that into your calculation part. We are depending only on sodium and hydrogen. We are depending only on sodium to hydrogen, nothing else. So we want only hydrogen. Okay, then we'll go for another part using our original equation after balancing. So what is our original equation? That is 2Na plus H2O gives rise to 2NaOH plus H2. In the original equation also, we'll go for the same relation. right? Here, what is our relation? Sodium to the hydrogen from the question. So I want the masses of here sodium with given coefficient and hydrogen. Remaining not required. But we'll give in the calculation, right? Then how to find the atomic masses. So this is your second step. Identifying the relation from the question and finding the atomic weights. So 2 is the coefficient. I am taking ISTs. Then here, sodium atomic weight, 23 units. No coefficient. No coefficient I am taking. H2. So 2 atoms there. That 2 I am taking into calculation part. This is. Here coefficient, nothing is there. That coefficient is 1. Don't get confusion. Then hydrogen atomic weight is 1 unit. Then 2 into 23 is what? 46. 1 into 1 into 2. That will give you 2. So here, simply what I have to understand from this, here 46 grams of sodium reacting with water and producing 2 grams of hydrogen. How many grams of sodium reacting? 46 grams. How many grams of hydrogen liberated?
2 grams.
So up to here, second step. Is it clear? Second step. Then I'm going for the third step in our calculation part. So look at that third step here. So now, using the same relation, what you observed in your second step. So sodium to the hydrogen. According to your original equation, here is original equation. 46 grams is reacting with water and producing 2 grams of hydrogen. According to your relation from the question, this one here is given. 230 grams of sodium reacting with water and producing what amount? Question mark. Not given. So here I'm taking that as unknown value. X grams is produced. No, X is produced, not grams. So here, using the law of constant proportion, the ratio is always same. Then the cross products becomes equal. According to law of constant proportion, that ratios are same. So from that, what we are saying, that cross product must be equal. So here, into 46 is equal to 2 into 230. Cross product is taken. Right? Here, I want X equal to, so remaining I am transposing towards right. So 2 into 230 ISTs, I am not multiplying, divided by 46 here. Okay, then cancellation part. So here cancellation with a 2 table, 23 times, 23 table, 10 times. So what is remained here? 10 grams. So here, what amount is produced? 230 grams of sodium reacting with excessive amount of water and producing 10 grams. Okay, then I'll give you a small relation here only. Just observe these two. Just observe these two. What you are observing. 2 and 10. 2 and 10. What is the ratio?
2 is to 10.
2 is to 10 means becomes 1 is to 5. Right? Here simply you said 2 is to 10. So cancellation is possible 1 time, 5 times. So it becomes 1 is to 5 times. Then look at here also 46 to 230. What is the ratio?
46 is to 23.
46 is to, okay, 23 2 times, so 23 10 times. Then 2 5 times. So same ratio is there or not? So same ratio is there. How many times that sodium increased, that many times our product is increased. This is law of constant proportion. Okay, if this is not there, right? Suppose one is raised 5 times and the other is raised only 1 time or 2 times. Is it correct ratio? Which is available? In that case, which is available least amount? Then it's a requirement. I required 5 times, but only given 2 times. So it is given less number of times. So that substance which is available less than the required quantity called a limiting reagent. Excessive amount of water is given. But whatever it may be, it is given, it will combine in the same ratio. So it is always combining with the other substance in the same ratio. It won't react to more or less. Okay, so it is. Keep this in mind. Then we'll go for the third step. Sorry, here third step completed. Right? So this is your step 3. Okay. So step 1, step 2, step 3 completed. What is step 1? Checking the equation. Is it balanced or not? Look at here. I have that. Just checking the equation. Is it a balanced equation or unbalanced equation? If it is unbalanced equation, make it balanced one. That is your first step. Then second step is finding the masses and identifying the relation. Okay. Next, third step, finding weight here. Product or requirement. What the question is given you according to the question. Then we'll go for the next step. So here, atomic weight completed. What are the other possibilities are there? Asking molecules and volume. So using here molar concept, right, in the both. Suppose step 4, I am considering that ask to find out the number of molecules. Okay. Step Y, I am considering finding the volume. Okay. Number of molecules and finding the volume. So in the both cases, we will use molar concept. So what is molar concept? Having Avogadro number of molecules. That is 6.023 into 10 to the power 23. In what amount of substance? Only in 1 mole substance. What is 1 mole actually? What is 1 mole actually? We are considering 1 mole is nothing but gram molecular weight. 1 mole is equal to what? Gram molecular weight. What is gram molecular weight? Suppose here I have hydrogen, right? Without coefficient. So the weight given by this hydrogen without coefficient is 2 into 1, that equal to 2. So this is only its gram molecular weight. Suppose that has any coefficient. Suppose it is given as 2H2. It has coefficient, right? It is now I am taking 2 times to the hydrogen. Its subscription is 2 and its weight is 1. Then I am getting 2 times 2, its gram molecular weight. So here I consider 2 grams size 1 mole. Here 2 grams 2 times, it is considered to be 2 moles. So what to understand here? What is the coefficient available before the compound formula? That is indicating us number of moles. Right? For example, we will go to our equation. Here look at. I am taking the coefficient as number of moles here. 2 moles of sodium, 2 moles of water molecule, 2 moles of sodium hydroxide. Here nothing is there. This is, we'll take it as 1 mole. Clear? The coefficient before the compound formula in a reaction tells us number of moles. So, in our reaction, how many moles of hydrogen is produced?
2 moles.
2 moles. 2 moles atomic weight is what?
10 grams.
No. See
2 grams.
See the
1
coefficient.
gram.
2 grams. Right? Okay. After the changing of sodium mass, how many grams of hydrogen is produced?
10 grams.
If you take 230, it is given you 10 grams. What is the ratio? 5 times.
5.
That only I asked here, 1:5. So 5 times increase. So how many moles? 5 moles.
5 grams.
Okay, so that we will understand from this. So here what to do? Simple, we will follow the same relation. According to the original equation, right? How many grams you have in your original equation?
2 grams.
Gram molecular weight without coefficient. 2 grams.
2 grams.
So 2 grams of hydrogen contains what? Avogadro number of molecules, 6.02 10 to the power of 20. Then what amount of hydrogen is produced here?
2 grams. 10 grams. 10 grams.
10 grams. Our product is 10 grams. So what amount of hydrogen? 10 grams. So 10 grams of hydrogen contains dash number of molecules. So that I am taking as here unknown value, certain amount y. Then following the same cross products are same using the ratios, law of constant proportion. So 2 into y is equal to 10 into 6.023 into 10 to the power of 23. See here, y is equal to what I will get? 10 into 6.023 into 10 to the power of 23. 33, sorry, here wrong written, 23. Okay, so 10 to the power of 23 number of atoms by 2 transposed. Then see here, if I cancel here, what I'll get? What I'll get? 5 times. How many times increased?
10 times. 5 times.
5 times. See what I am given in the previous step number 3, that ratio. In the same ratio, you are getting the number of molecules. Yes. So simple to answer in MCQs, right? No need to follow this all the steps. Only in long answer type or only in a 4 marks question, we will follow these steps. Okay. Right. So here multiply. What you will get? 30.0115 you will get into 10 to the power of 23. If you restrict these decimal point only single place, so it will become 3.0115 into 10 to the power of 24 molecules. So volume also same. 2 grams occupies 22.4 liters. Then what about 10 grams? That unknown value, I will take Z. So cross product also equal here also same. So here Z is
22.4 into 5.
equal to 22.4 into 10. Transposing, what I will get? 22.4 into 10 by 2. Z equal to. So here again cancelling, what I will get? 5 times. That equal to what? 22.4, 10 times 224, half, 112 product. This is the answer, right? So that volume also rised in the same ratio. So this is the solution. Finding the molecules, finding the volume, and finding the atomic weight